students, myself Nandini. I am going to take Strength of Materials, which is in the third semester of Civil Engineering. At this, I am going to take Unit 1, Stress, Strain and Deformation of Solids. So, we have already seen about stress and strain in the engineering mechanics that you have studied in the second semester. So now we are going to see what is stress, what is strain and deformation of solids. So first objective of this strength of material is we have to classify the loads . We have to classify the loads and the effects of different kinds of load and what are all the types of stresses that is developed due to the applied loads. So what is mean by load? The external member of the material. The load is acting on the material, that is known as loads. So what are the types of loads means? That may be tensile load, which is acts away from the material, and compressive load, that is acted towards the material, and shear force, that is a transverse load. So in case of material is like this, the shear force will be act like this or in this way. So these are the types of loads we are going to study in this unit. Next, to understand the effects of load. So what are the effects? There will be some effects due to tensile load and compressive load and shear load. So these are all the effects of loads we are going to see. So to know the different types of stresses means the types of stresses are corresponding to the types of load that is going to happen inside the material. So what are all the types of stresses? So tensile stresses, compressive, and shear. So these are all the types of stresses we are going to study in this unit. So next is outcomes of the lesson. With these objectives, we are going to learn about what is stress, what is strain and what is principal strain and principal stresses. So what are the prerequisites knowledge have to keep in mind is these are the things. So in the previous semester, that is in the second semester of engineering subject, we have studied what is engineering mechanics. From this we have known statics and dynamics. But what is mechanics? So we didn't see about mechanics of the materials. We have studied what is statics and what is dynamics. So what is statics means? The study of external effects of materials. So what is the external effects such as friction we have studied in engineering mechanics, and what is dynamics, impact loading we have studied. But mechanics of material deals with the study of internal effects. What is internal effects? That is Newton's third law. So for every action there is an equal and opposite reaction exists. So if we put some loads here, there will be some reaction inside the material. That is known as mechanics of materials. The study of internal effects on the material is known as mechanics of materials. Why we have to study about the inside reactions? So if we use some kind of materials like wood or steel, we are going to use in our construction. In case if there is any loads occur means we have to know what is the inside reactions developed. So for that we will design it earlier. Before going to construct any building, we have to know the mechanics of materials. So mechanical properties should be known to every engineering students before doing a construction. So next is, these are all the other terms we are using for mechanics of materials. So mechanics of materials we have seen, strength of materials we are also called, mechanics of deformable bodies and mechanics of solids. These are the terms we are going to use in this unit. So what are the approaches we are going to see in this unit means logical development of the concepts. What are the logical developments? So if some forces are applied, the effects will be the logical approach of the concepts. So logical development of the concept and application of the concept. So logical development in the sense, if we analyze a body by applying certain loads, the logical approaches term, what is the logical development means? The reaction developed inside the material and how much load is applied and how the material will get deformed. That is the logical development of the concept. Next is application concept in the sense, if we apply a load in the material, there will be some deformation, like this is the L part of the material, that is the length of the material. This is somewhat extension occurred due to applied load. This is the application part of the approach. So application part means there is numerical and algebraic concepts. So what is numerical and algebraic means? Numerical is we are going to solve some problems related to the application of loads. Algebraic means we are going to derive some formulas around the concepts, means that is algebraic approach. So the basic units we are going to use in the first unit itself is, so first one is meter, that is used for measuring length. So meter is used for lengthwise concepts, and Newton or kilonewton will be used for weight calculation, and seconds is used for time calculation. So the length will be used for the measurement of size. So that will be a horizontal length or vertical length of the material. And kilonewton or Newton is, we are going to apply loads on the material. So that load will be indicated in the Newton or kilonewton. So these are the basic units we are going to use in this topic. So next is body force. So body force is the general term or basic term we are going to use in this unit. So depending upon the body force only, we are going to analyze the deformable bodies. So one is gravitational force, another one is inertia force, another one is magnetic force. So these are the forces we are going to apply on the materials. So first, very basic thing we are going to study in this unit is stress. So what is stress? So if we apply some forces in the material, in this I am using tensile force. So stress is nothing but the internal resistance developed in a body. So for example, if some forces, somebody pushes us or pulls us to some extent, we hold like a rigid body. So some extra force will acted upon us, means we are getting some stress. That is known as internal resistance. So it is nothing but, if apply a force, there is an equal amount of internal resistance will be developed if we cut a plane across the body. So in simple words, that is I have already told, this is known as Newton's third law. For every action there will be an equal and opposite reaction exists. That is known as stress. Stress is nothing but the simple sentence. In one sentence we are going to define the stress, the internal resistance developed in a body. So nothing serious. The only statement we are going to define is the internal resistance developed in a body. This is an important 2 mark for unit 1. Define stress. So this is application format. I have already told there is 2 approaches available. One is logical approach and is application concepts. So one is logical approach, we are defining it. Another one is application approach, means this will concluded into a formula. So stress is defined as internal resistance, that is P, with where it is applied, unit cross sectional area. So sigma is defined as load per unit cross-sectional area. This is the stress definition. So for the formula for unit for stress is P is we are applying a load, that is Newton or kilonewton. Area is mm square. So the unit for stress will be Newton per mm square. So next is strain. So if we apply some forces, there will be some deformation occurs. That part is known as strain. So strain is nothing but if we apply some force, the body will get some deformation. That deformation is known as strain. So if we apply a load of P along the axis of the body, so the length will get some deformation. This deflection is known as strain. So how we will define the strain means epsilon, which is equal to del L, that is change in length divided by original length. This is the strain formula. So not only in the lateral direction, longitudinal direction, it will be applicable for lateral direction also. So in case the load will be, this diagram shows the longitudinal approach of the strain part. I will explain the lateral direction. So if we apply a force like this, the diameter of the lateral dimension of the material will get expands like this. So this portion is known as delta D. So this is the diameter of the material. If we compress it, it will get elongated laterally. Then it will get some deformation delta D. So the epsilon strain formula will be written as del D divided by original diameter. So strain normally commonly defined as delta epsilon equal to change in dimension, that may be lateral or longitudinal. Change in dimension divided by original dimension. So if we apply some forces, the material will get elongated or compressed. That part is known as strain. Change in dimension divided by original dimension. So why we are going to study this topic means, if we use steel or wood in our construction, there will be some deformation in the future due to some effects. That effects may be winter or summer. So those effects, we can see in our old buildings, the windows got stuck. This is due to the expansion due to summer effects or cold or climatic changes. The wood will be expanded. So the windows got stuck. So for that reason, we have to study what is stress and what is strain in the materials. That whole concept is concluded in this topic. So next is types of stresses. I have already told what are all the types of stresses, that is compressive stress, tensile stress, compressive stress, tensile stress, shear stress, torsion and bending. So compressive stress in the sense, if we apply compressive force, there will be a development of compressive stresses. If we apply tensile force, there will be a development of tensile stresses. If we apply shear force, there will be a development of shear forces. So for that, but what is torsion? This part is very, very important. For civil engineers and mechanical engineers, torsion takes an important role in their studies. So what is torsion? The twisting moment. Simple. So if we apply a load using our normal empty towel means, it will make some amount of force. But if we twist the material and make a force means, it will develop some extra amount of force. That is known as torsion. So bending means, for civil engineers, we must know what is bending. So if we apply a load on this slab, this may be like a slab. So this will develop some bending stresses into the material. So these are all the types of stresses. Stress strain curve for mild steel bar. So stress strain curve is a very, very basic topic in strength of materials. So what is stress strain curve means? this is stress and this is strain. The curve will be like this. So this is the basic mild steel curve, mild steel stress strain curve for a mild steel bar. This is very important in strength of materials unit. So what this curve represents means there are 6 points like this. So what is point A means? A represents limit of proportionality. Limit of proportionality. So first I explain all the points, then I will elaborately explain the remaining points. So first one, A is limit of proportionality. Then second point is elastic limit. B is elastic limit. Then third one, C is upper yield point. Upper yield point. And D is lower yield point. And E is ultimate point. So for a stress-strain relationship, why we are going to study these points, I'll explain. So E is ultimate point and F is, as it starts, its failure point. So this is very important in strength of materials unit 1. So this is the basic stress strain curve. So always we are putting stress in the y direction and strain in the x direction. So what is this curve explains means, first point is limit of proportionality. So we all know Hooke's law. What is Hooke's law? Within the elastic limit, stress is directly proportional to strain. So up to this point, the stress is directly proportional to strain. So with the deformation, and there is an increase in stress. This is explained in A, limit of proportionality. And what is B represents? So I have already told, Hooke's law is stress is directly proportional to strain. So if we apply some force in the material gets deformed to some extent, but after release of the application of force, the material will get its original position. That is known as elastic limit. Even we see a rubber, the rubber will extend while we apply force. Then it will regain its original position after the release of the original force. That point is known as elastic limit. In the same means, mild steel also behaves like a elastic material up to B point. So next is yielding. So what is yielding? If we apply some force in the material, the material tends to deform. The initial deformation occurs. That point is known as C. So now what is lower yield point means? The material starts yielding. So this stress strain curve is derived from a tension test of a mild steel bar of 10 mm rod. The bar will the specimen of this test will be like this. We will put this in the UTM machine that is available in the strength of materials lab. If we apply this material in the UTM machine, it will get deformed like this. So this is the end specimen. So this portion is called the yielding material, yielding portion. So after that it will get some ultimate limit. So after that it will get break. will get broken into two pieces. So this is the mild steel stress strain curve for a mild steel bar. So from this we are going to study this in both the unit itself, strength of materials unit itself, and then in the laboratory itself we are going to study these topics. So thank you so much for the session.